All right, welcome back to section 2, and this is angles and standard position. So, what we've talked about before, we can draw any type of angle, okay? You know, it doesn't matter where those are oriented or anything like that. We can draw the angle and measure the angle in degrees, okay, in degrees. Okay, but we're talking about the anatomy of an angle, okay, and we have what's called a terminal side and the initial side. Now, in standard position, the initial side is horizontal, okay, and that's how we kind of will be talking about angles from here on out, and knowing that we start with this initial side, and then we have a terminal side, which is not horizontal. Okay, so this is non-horizontal. Okay, and just so we're kind of clear on some of the vocab, this little point here is called the vertex, okay? And that's where the two rays meet, where the angle is formed, okay? So that's the idea. Now we're going to take this idea and we're going to apply this concept of an angle on the coordinate plane. Okay, so that's what we're going to do on the next page. Okay, on this page we're going to talk about angles in the coordinate plane. All right, and what I'm going to do here is kind of just draw a typical angle that we would have in standard position. So I put my vertex at the origin. I put my initial side along the x-axis, and then I draw my other side, my terminal side, going away, okay? Now, we would measure this in degrees, okay? We have some sort of degree measure, all right? But we also have another angle here. We have another angle that makes this big angle, okay? And so we're going to kind of talk about that, all right? When you go, I do want to write this down. When we go clockwise, or I'm sorry, counterclockwise, our angle measures, angles are positive, okay? If we go clockwise, okay, our angles are negative, okay? But we're going to start doing this quite a bit, where we have angles in the coordinate plane, and we're going to use that in, you know, with circles to help us figure out what points on a circle are. So we'll go on to that, but the idea is we need to get used to the idea of having angles, vertex at the origin, having our initial side here, and then our terminal side here, okay? Now, what we have here is we have this 45-degree angle. It's in standard position, okay? Now, what I want to do is kind of talk about something a little bit brand new. Maybe you've seen it before, maybe you haven't. But if I take this angle here, all right, and I make a full revolution around this circle, my total angle measure is 360 degrees, okay, a full revolution. Now what we'll do is we'll be able to do multiple revolutions and figure out angles, but coterminal angles are angles that add up to 360 degrees. So angles that add to 360 degrees. Okay, so when I look over here, I have two angles. Okay, we had that initial angle here that was a 45-degree angle. Okay, vertex is at the origin. Our initial side is along the x-axis. Okay, but we also have this other angle here. Okay, that starts here at the origin and goes the other way. Okay, And so what I have, and to figure that out, figure out what this angle is I take 360, which is my total circular revolution, and subtract 45 from that to give us 315. But we also have to think about direction. Okay? Are we going clockwise or going counterclockwise? Because this one is going counterclockwise. You start at this line and you go up. And so you have a positive angle measure. But because here we were going clockwise from the x-axis and going around, we had a negative angle measure. Okay? And that's what we kind of have to think about. So that's all I got for this one. Okay, never mind. I forgot about something I needed to talk to you about. And let's kind of draw that here. Let's talk about something that goes around the circle more than once. Okay, so let's draw an x-axis and a y-axis. And let's draw a initial side here. Okay, and let's say that I go around, I revolve this, my angle, numerous times around the origin. Okay. So let's do this. Let's say I revolve this around once. Okay, when I make that one revolution, that means I've gone 360 degrees. Okay, and then I go around again, that's 2 revolutions, and then I make another revolution here. Okay, and let's say that my angle measure was here. And let's say that the angle measure from here to here is 45 degrees, okay? So here's what I've got. I have this little thing down here. It says angles with measure m plus 360n are coterminal with an m degree angle where m is any real number and n is any integer. So I'm going to have this. I'm going to have n be n equal the number of revolutions. Okay, and then m is your just angle measure. Okay, so when I went around this circle, I went around once and then twice. So I went around 2 revolutions. So I need to take, I have n equals 2, so I'm doing m plus 360 times 2, and then I need to add in that angle measure. Now, when I have this is 180 degrees. Okay, so from here to here is 180, and then I'm going to add another 45 degrees. Okay, so m is equal to 180 plus 45, which is 225? 225 degrees? Okay, and so let me add that in. Let me do 225 plus 360 times 2. Let's plug that into the calculator real quick. So we get a total angle measure of 945 degrees. Okay, so and the thing you have to kind of think about is just each revolution is 360. So think about how many times you revolve around that axis, and then what's that final angle measure going to be? So take that number, you know, however many times you go around, multiply it by 360 degrees, and then add your other angle. That now should be it for this video.